You have most likely been exposed to areas of mathematics like algebra, the study of operations, and geometry, the study of shapes. Calculus is the mathematical study of change. Calculus comes in two major branches. These are differential calculus and integral calculus. These are related to each other by the fundamental theorem of calculus. Both of these areas of calculus use the idea of infinite sequences converging on a limit. A limit is the y value that a function approaches as the x value approaches a point. A limit is commonly notated as the limit as x approaches a value of a function. Before we get into limits, let's talk about infinite series. For our first example, let's use a length of 2 meters. We will travel along these 2 meters by continually halving the distance from us to our endpoint. By continuing to travel like this, it seems like we will be traveling forever, never reaching our endpoint. But if we imitate this in real life, of course we will hit our endpoint. This is known as Zeno's paradox. Let's look at this mathematically. First, we can write a series of all the distances that we travel, starting at 1 and then halving each number. If we half this series that we have now, we get the same series of numbers except that it starts at 1/2. Now let's subtract the two equations from each other. It turns out that everything cancels out except for 1. So 1/2 of our series equals 1. This means that our original series is equal to 2. This is an example of how you can find the value that an infinite series goes towards. Using the same idea, we can find the value that a function approaches, whether it is a certain x value or a function that goes to infinity. These are limits. We can see where a series of numbers is going even if it never actually gets there. Derivatives study rate of change. The derivative of a function is the slope at any certain x value. The derivative of a function is often notated as f prime. Usually, we use derivatives to find the rate of change of functions, such as curves. So now the problem arises of being able to find a slope of a curve, or the slope of a line tangent to the curve. Usually, to find the equation of a line, you need 2 points. Say we have a curve. We can approximate a tangent line by zooming into our curve and using 2 points that are very close to each other. We can approximate the slope of the tangent line by measuring the change in rise over run between these 2 points. This change can be showed by the following expression, where x is the location of the tangent line and h is the distance to the second point. By moving these points closer and closer, our tangent line and its slope become more accurate. If we take the limit of this slope as the distance between these points approaches 0, we are left with the actual slope of the tangent line. This is where we get the definition of derivative formula. F prime is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. From this definition, we get rules such as the power, product, quotient, and chain rules. Using these rules simplifies differentiating by making it so that we don't have to always use the derivative formula. Finally, using the fundamental theorem of calculus, we can relate the area under a curve to our antiderivative. This is where integral calculus comes from. I may go into proving integral calculus later, but for now, that's all, folks.